Okay, this is lesson 3.1 for course 2. So in lesson 3.1, you need to write down some key vocabulary terms. The first one is called a benchmark. So write down a benchmark is a convenient number used to replace fractions less than 1. So you can use the benchmarks 0, 1/2, and 1. So these are the three benchmarks that you can use. It's kind of like money. So if I go to Meijer and a candy bar is 59 cents, I kind of just assume, oh, it's 50 cents. Or if something is 89 cents, I would say, oh, it's about $1. It's what we use in our everyday lives and shopping and all of that. So here are some examples. 2/9 is right about here on the number line. So they would say 2/9 is really small. So a good estimate or a good benchmark would be 0. 4/9 or 7/12 are about in the middle. They're about half of the denominator. 4 is about half of 9 and 7 is about half of 12. So those, a good benchmark would be a half. And then any large fractions like 7/8, 9/10, all of those ones where the numbers are real close to each other, those are, 1 is a good benchmark for those. So, what you're going to see, it says using benchmarks with fractions. So, a family bought a plot of land last year that was 4/9 of an acre. They plan to buy an adjoining plot this year that is 7/8 of an acre. Estimate the total amount of land the family will have. Now, in this very beginning lesson, we're just estimating. So there's the key word, estimate. We don't have to find the real answer. That's later on in the book. So what they did is they said, okay, 4/9 plus 7/8. 4/9 plus 7/8. So write that down in your book or in your notes. 4/9 plus 7/8. And then they put these little squiggly equal signs because those mean approximately equal to. And then they said 4/9 is about 1/2 and 7/8 is about a 1. So it would be 1/2 plus 1. So the total acreage would be 1.5 acres of land. So try this one. Use benchmarks to estimate 3/5 minus 1/8. Push pause, try this problem, and then we'll come back. All right, so if I have 3/5 minus 1/8, I am going to estimate 3/5 is about a half. Remember, for benchmarks, you can only use 0, 1/2, and 1. You have 3 benchmarks. So that's what you should be using when you estimate, those 3 numbers. So I'm going to say 3/5 is 1/2 and 1/8 is 0. So 1/2 minus 0 is 1/2. All right, to estimate a sum, difference, or product of mixed numbers, you can first round each mixed number to the nearest whole number and then compute. So what they want you to do here is round it to the nearest whole number. So write this down. If it's a mixed number, I'm going to round to the nearest whole number. Okay, so here's an example. For an experiment on plant growth, you recorded the height of a plant every day. On Monday, the plant was 5 1/4 inches tall. A week later, it was 10 7/8 inches tall. About how many inches did the plant grow? So, I'm going to take my larger number, which is 10 7/8, and I'm going to subtract my smaller number, 5 1/4. So, they want me to estimate. It says about how many inches did the plant grow. So, I'm going to estimate. And when it's a mixed number like this, I round to the whole number. So 10 7/8 would round to 11, And 5 1/4 would round to 5. So you would just do 11 minus 5, which is approximately 6. I put those little equal to signs that are squiggly because 6 is not the exact answer. That was just my estimate. So try these 3 problems, A, B, and C, and notice it says use rounding to estimate each product. Product means these are all multiplication problems. So try these 3, and then we will come back and correct. All right, so 3 5/6, that would round to 4. I'm rounding to the nearest whole number. 5 1/8 would round to 5. So 4 times 5 is 20. 8 1/8 would round to 8. 5 11/12 would round to 6. I'd round it up because 11/12 is almost whole. So I'd round it up to 6. And then 8 times 6 is 48. 7 1/3. Now this one's pretty tricky, but it's 1/3, so I'm going to go down. I'm going to round to 7. And 1 13/16, that's pretty high fraction, so I'm going to round it to 2. So 7 times 2 is 14. All right, so use compatible numbers to estimate each quotient. So one thing I want you to write down in your notes is compatible numbers. All right, so compatible numbers are used in division, so it's for division, and it's when you want to use numbers that easily divide into each other. So it's for division, and you're going to use numbers that easily divide into each other. So, if I had 22 divided by 5, those are not compatible numbers because they do not easily divide into each other. So what I would do is I would make this 20 divided by 5, which equals 4. So those are compatible numbers because they easily divide into each other. So let's try this first one, and then you can try the other ones. So I have 35 3/4 divided by 5 11/12. So I'm going to round this to 36, and then I'm going to round this up to 6 because I want something that will easily divide into 36. And 36 divided by 6 is 6. So try B and C, and then we will correct. All right, so for B, I look at my number and it's 22 7/8. Now, if I round that to 23, I can't really divide by a 3 or a 4. Neither of them work. So those are not compatible numbers. So what you want to do is round it a little bit higher to 24, and then I can divide it by 4. So then I can divide that by 4, which makes it a nice, easy division problem. That's what you're looking for. You're looking for an easy division problem. So 46 2/5. If I round that to 46, that does not divide easily into 5. So those are not compatible numbers. So what I'm going to do is I'm going to go down even more and go to 45 because that divides really nicely into 5, which equals 9. So you might have to go a little bit far on your estimating, but do that to make the problem easier because division can get really messy. We want to keep it nice and clean. All right, that is it for your notes.